There's a fabric so rare, so impossibly soft, that for centuries it was reserved only for emperors and kings. A single sweater can cost more than a month's rent. A scarf might carry a price tag that makes you question reality itself. But here's what almost nobody knows. This legendary material doesn't come from sheep grazing on green pastures, or from high-tech laboratories spinning synthetic miracles. It comes from goats. Not just any goats, but animals living in one of the most extreme, unforgiving environments on Earth, the windswept plateaus of Mongolia and the freezing highlands of Kashmir, where temperatures plunge to 40 degrees below zero. Welcome inside the hidden world of cashmere production, where ancient herding traditions collide with cutting-edge industrial engineering, where a fiber thinner than a human hair becomes the ultimate symbol of luxury, and where the journey from a remote mountainside to a Manhattan boutique involves processes so precise, so demanding, that most manufacturers guard their techniques like state secrets. Right now, as you watch this, there are approximately 60 million goats across Asia producing the raw material for cashmere. But here's the shocking truth. It takes the annual harvest from 4 to 6 goats to create just one cashmere sweater. That's why cashmere remains one of the most expensive natural fibers in the world, commanding prices 8 to 10 times higher than wool. The global cashmere industry generates over $4 billion annually, yet most people have never seen the inside of a processing facility, never witnessed the transformation from coarse animal fiber to the softest fabric imaginable. What you're about to discover will change the way you look at every cashmere garment forever. Because behind that elegant label, behind that cloud-soft texture, lies an industrial process so intricate, so technologically advanced, that it borders on alchemy. From the high-altitude collection sites where herders manually comb goats during the spring molting season, to the massive sorting facilities where workers separate precious cashmere from coarser guard hairs under magnification, to the chemical baths and mechanical treatments that transform raw fiber into textile gold, every step reveals hidden complexity that few outsiders ever witness. The cashmere you touch in stores has traveled thousands of miles, passed through dozens of hands, survived brutal quality controls, and emerged from machinery so specialized that only a handful of factories worldwide possess the complete capability to process it from raw fiber to finished fabric. This is that story. This is the secret process behind luxury fabric. Before cashmere became synonymous with luxury, it was simply a survival mechanism. The cashmere goat, scientifically known as Capra hircus laniger, evolved one of nature's most remarkable insulation systems, a double-layered coat consisting of coarse outer guard hairs and an incredibly fine undercoat that keeps the animal warm in the brutal Himalayan winters. This undercoat, the true cashmere, consists of fibers measuring just 15 to 19 microns in diameter. To put that in perspective, a human hair averages 70 microns. This extraordinary fineness is what gives cashmere its legendary softness and warmth-to-weight ratio that surpasses virtually every other natural fiber. The history of cashmere is steeped in geopolitical intrigue and trade route drama. The fabric derives its name from Kashmir, the disputed region between India and Pakistan, though most commercial cashmere today comes from Mongolia, which produces approximately 9,000 tons annually, roughly 65% of global production. In the 15th century, Kashmiri weavers created shawls so exquisite that they became currency among European aristocracy. Napoleon famously presented his wife Josephine with dozens of cashmere shawls, sparking a fashion obsession that drove demand through the stratosphere and led to attempts to steal the production secrets. But here's something most people don't realize. Not all cashmere is created equal. The finest cashmere, known as pashmina, comes from the throat and belly of the goat, where fibers measure 14 to 16 microns, the absolute pinnacle of softness. Chinese cashmere tends to be coarser at around 90 microns, while Mongolian cashmere averages 15 to 16 microns and commands premium prices. Iranian cashmere, though less common commercially, is prized by connoisseurs for its exceptional length and strength. The color spectrum ranges from white and gray to brown and even rare black, with white being most valuable because it can be dyed any color without pre-bleaching. The economics of cashmere production reveal why authenticity matters so intensely. Each goat produces only 4 to 6 ounces of usable cashmere per year, barely enough to fill a coffee cup. After processing removes coarse guard hairs and impurities, that amount shrinks by 30 to 50%. This means approximately 150 grams of pure cashmere fiber per goat annually. When you calculate that a standard sweater requires 200 to 300 grams, the mathematics of scarcity become clear. This biological limitation creates inherent value that no industrial innovation can overcome, which is precisely why cashmere fraud remains a persistent problem, with cheaper fibers frequently blended in or substituted entirely. Climate plays an unexpected role in cashmere quality. The harshest winters produce the finest cashmere because goats develop denser, finer undercoats in response to extreme cold. Mongolian herders report that winters reaching -40 degrees Celsius result in superior fiber crops the following spring. This creates a paradoxical relationship where climate change threatens cashmere quality. Milder winters mean coarser fibers. Scientists studying cashmere-producing regions have documented a measurable decrease in fiber fineness over the past 2 decades, correlating directly with rising average temperatures. The cashmere industry faces environmental controversies that rarely make headlines. Overgrazing by cashmere goats has contributed significantly to desertification in Mongolia and parts of China. The goat population in Mongolia exploded from 5 million in 1990 to 27 million by 2016, driven by international demand for luxury goods. Unlike sheep, which bite grass, goats pull plants out by the roots, devastating grasslands. This has accelerated the expansion of the Gobi Desert by thousands of square kilometers. Some manufacturers now promote sustainable cashmere initiatives that limit herd sizes and implement rotational grazing, though these programs remain relatively small-scale compared to conventional production. Here's a fascinating industrial secret: the cashmere you buy isn't necessarily new. High-quality cashmere can be recycled multiple times through a process called reprocessing or regeneration. Factories collect used cashmere garments, mechanically shred them back into fibers, blend them with virgin cashmere, and respin them into yarn. Italy leads this recycling technology, with facilities in Prato processing thousands of tons annually. Recycled cashmere typically gets blended at ratios like 70% virgin to 30% recycled, maintaining quality while reducing environmental impact. The industry rarely advertises this practice, but it's completely standard among premium manufacturers. The counterfeiting problem in cashmere extends beyond simple substitution. Sophisticated fraud involves treating regular wool with enzymes and chemicals to partially dissolve the outer scales, making it feel temporarily softer, soft enough to pass initial touch tests. Other schemes involve blending tiny percentages of cashmere with large amounts of viscose or acrylic, then legally labeling the product as containing cashmere. Laboratory testing using microscopy or DNA analysis can definitively identify cashmere, but these tests cost hundreds of dollars per sample, making them impractical for most consumers. Industry estimates suggest that between 20 and 40% of products labeled as 100% cashmere contain significant adulterants. Subscribe to our channel and hit the like button to discover more hidden manufacturing secrets that reshape how you see everyday luxury items. Color science in cashmere reveals unexpected complexity. Natural white cashmere can be dyed virtually any shade, but colored cashmere presents challenges. Brown cashmere, for instance, contains melanin pigments that resist certain dyes and require aggressive bleaching treatments that can damage the delicate fibers. Gray cashmere offers a middle ground, desirable for its natural aesthetic but less versatile than white. Black cashmere, the rarest natural color, commands premium prices in Asian markets where it's considered particularly luxurious, though it cannot be dyed lighter shades. Professional dyers guard their formula zealously because achieving consistent, color-fast results on cashmere requires precise pH control, temperature management, and chemical selection that differs substantially from all dyeing. The genetic science behind cashmere production is advancing rapidly. Researchers in Inner Mongolia and Australia have identified specific genes responsible for cashmere fineness, yield, and growth rate. Selective breeding programs now use DNA markers to identify superior breeding stock, potentially increasing cashmere yields by 20 to 30% over the next decade. Some experimental programs explore crossbreeding between different cashmere-producing goat populations to combine the fineness of Mongolian stock with the yield quantities of Chinese breeds. These genetic improvements could eventually democratize cashmere availability, though purists argue that industrial optimization threatens the fabric's exclusive character. Historical production methods reveal just how far cashmere manufacturing has evolved. Traditional cashmere processing involved washing raw fiber in river water, air drying it on riverbanks, hand combing to remove guard hairs, hand spinning on wooden wheels, and weaving on manual looms, processes requiring 6 months or more per shawl. A master weaver could complete perhaps 2 or 3 shawls annually. Modern industrial processing accomplishes in hours what once took months, though many luxury brands still incorporate hand finishing for their premium lines, recognizing that certain qualities, particularly the subtle irregularities that signal authenticity, cannot be replicated by machines. The cashmere supply chain begins in regions most luxury consumers will never visit. Mongolia's Gobi Desert, the Tibetan Plateau, and the highlands of Kashmir, Ladakh, and Iran represent the primary production zones. Here, temperatures range from 50 degrees Celsius in summer to -40 in winter, creating the environmental stress that triggers exceptional undercoat development. Herders, many maintaining nomadic or semi-nomadic lifestyles passed down through generations, manage goat herds numbering from 50 to several hundred animals. These aren't farms in any conventional sense. They're vast open-range operations where goats roam freely across territories spanning dozens of square kilometers. Collection happens during the spring molting season, typically March through May, when goats naturally shed their winter undercoats. Professional herders employ one of 2 primary harvesting methods: combing or shearing. Combing, the traditional and superior method, involves manually combing the goat's undercoat with specialized wide-toothed combs, separating the fine cashmere from coarser guard hairs during the collection process itself. A skilled comber can harvest 1 goat in approximately 30 minutes, yielding the purest, least contaminated raw material. This labor-intensive approach is increasingly rare due to cost pressures. Shearing, the industrial alternative, uses electric clippers to remove the entire coat at once, both undercoat and guard hairs, creating a mixed product requiring extensive sorting later but reducing collection time to just 5 to 10 minutes per animal. Raw cashmere arrives at processing facilities in massive compressed bales, often weighing 150 to 300 kilograms each. The material at this stage bears no resemblance to the soft fabric you recognize. It's greasy from natural lanolin oils, contaminated with dirt, vegetable matter, and debris, and mixed with coarse guard hairs that must be meticulously removed. The fiber appears matted, discolored, and surprisingly rough to touch. Professional buyers assess raw cashmere using highly specialized criteria: fiber diameter measured in microns, staple length typically ranging from 30 to 45 millimeters, color consistency, contamination levels, and the ratio of precious undercoat to worthless guard hairs. The sorting process represents the first critical quality control stage. In facilities across China and Mongolia, teams of workers spread raw cashmere across illuminated tables and manually separate it by color and visible quality grades. This initial sorting determines which batches receive premium processing versus standard industrial treatment. Workers remove the most obvious vegetable contamination: twigs, seeds, grass, though microscopic debris remains embedded. The sorted cashmere moves to storage areas where climate control prevents moisture absorption that could promote mold growth or fiber damage. Large facilities process 50 to 100 tons of raw cashmere monthly during peak season. Scouring, the industrial washing phase, removes the natural grease, dirt, and remaining debris. Cashmere enters massive rotary washing machines, essentially giant perforated drums, where it undergoes multiple wash cycles using heated water and specially formulated detergents. Temperature control is critical. Water too hot damages the delicate fiber structure, while water too cold fails to adequately remove greasy lanolin. Modern facilities maintain wash temperatures between 45 and 55 degrees Celsius. The process uses enormous water quantities, approximately 20 to 30 liters per kilogram of fiber, making water recycling systems economically and environmentally essential. After washing, industrial centrifuges extract excess moisture, reducing water content from saturated to approximately 30 to 40%, preparing the fiber for drying. Drying happens in controlled environment chambers where heated air circulates through tumbling drums containing the washed cashmere. This stage demands precision because over-drying makes fibers brittle and prone to breakage, while under-drying creates conditions for bacterial growth and odor development. Industrial dryers maintain temperatures around 60 to 70 degrees Celsius, processing batches for 2 to 4 hours. Some premium facilities use low-temperature, extended duration drying to minimize heat stress on fibers, though this significantly increases processing time and cost. The dehairing process represents the technological heart of cashmere manufacturing, the stage where industrial magic separates valuable undercoat from worthless guard hairs. This separation exploits fundamental differences in fiber structure. Cashmere undercoat fibers are extremely fine, crimped, and relatively short, while guard hairs are much coarser, straight, and longer. Modern dehairing machines, which can cost upwards of $500,000 each, use a combination of mechanical and electrostatic separation principles. The fiber mass passes through rotating cylinders covered in thousands of tiny needles or teeth, which grab and pull the coarser guard hairs while allowing finer cashmere to pass through. Electrostatic charges enhance separation by exploiting differences in how the two fiber types respond to electrical fields. Multiple dehairing passes are standard for premium cashmere. First-pass machines remove the majority of guard hairs, typically reducing guard hair content from 30 to 40% down to about 10 to 15%. Second-pass machines, using finer settings, reduce contamination to 5% or less. Ultra-premium cashmere destined for luxury brands undergoes third or even fourth passes, achieving guard hair content below 2%, though each additional pass reduces overall yield and increases cost substantially. The removed guard hairs aren't waste. They're sold to manufacturers of cheaper textiles, brushes, and industrial felts. After dehairing, the cashmere undergoes carding, a process that aligns the chaotic fiber mass into parallel arrangement. Industrial carding machines feature large rotating cylinders covered with thousands of fine wire teeth. As fiber passes between these cylinders rotating at different speeds, the teeth catch, pull, and align individual fibers into the same direction. This creates a thin, web-like sheet called a card web or bat. Carding also provides additional cleaning, removing remaining vegetable matter and short fiber fragments that could create weak points in yarn. The carded web exhibits the first hints of cashmere's legendary softness, though still far from finished fabric. Dyeing can occur at multiple stages depending on manufacturer preference: raw fiber, yarn, or finished fabric. Fiber dyeing, called stock dyeing, offers superior color penetration and consistency. Cashmere enters massive dyeing vessels, essentially giant pressure cookers, containing water, dye chemicals, and various agents controlling pH, temperature, and dye uptake rate. The process typically runs 2 to 4 hours at temperatures between 80 and 100 degrees Celsius. Acid dyes are standard for protein fibers like cashmere, chemically bonding with the fiber at the molecular level. After dyeing, extensive rinsing removes unfixed dye, followed by drying and quality checks verifying color consistency across the entire batch. Spinning transforms aligned fiber into yarn through controlled twisting that binds fibers together via friction. Modern spinning frames contain hundreds of individual spindles, each producing a continuous yarn strand. The fiber feeds from carded slivers through drafting rollers that thin the material to desired yarn thickness, then into spinning mechanisms that introduce twist. Cashmere yarn is measured in count or gauge. Higher numbers indicate finer yarn. 2-ply 26-count yarn represents a common standard for quality sweaters, meaning 2 individual strands of 26-count yarn twisted together for strength. Ultrafine cashmere yarns used in luxury scarves might reach 40 or even 50 count, requiring exceptional fiber quality and spinning expertise. Quality control throughout processing employs both automated sensors and human inspection. Fiber diameter testing uses specialized microscopes with calibrated measurement systems, randomly sampling batches to verify micron counts meet specifications. Tensile strength testing pulls individual fibers until breakage, measuring the force required, critical for predicting yarn and fabric durability. Pilling resistance testing, where fabric samples undergo mechanical abrasion, predicts how the finished product will perform during wear. Color consistency gets evaluated using spectrophotometers that measure precise wavelengths of reflected light, ensuring batch-to-batch matching. These quality protocols separate premium manufacturers from budget operations cutting corners. Weaving or knitting creates the actual fabric. Weaving interlaces yarn at right angles on industrial looms, producing fabric with minimal stretch but excellent structure and durability. Twill weaves create diagonal patterns and enhanced softness. Knitting, more common for cashmere, loops yarn into interconnected structures, creating fabric with natural stretch and exceptional drape. Industrial knitting machines contain hundreds of needles operating in programmed sequences, producing seamless fabric tubes or flat panels. Gauge refers to needle spacing. Finer gauge means more needles per inch, creating denser, more refined fabric. Luxury cashmere typically uses 12 to 14 gauge knitting. Finishing treatments determine the final tactile quality. The fabric undergoes washing in industrial machines with controlled agitation, temperature, and chemistry, causing slight felting that enhances softness. Steaming relaxes fiber stress and sets the fabric's dimensional stability. Brushing passes fabric through rotating cylinders covered with thousands of fine wire bristles, raising a subtle surface nap that amplifies softness. Some manufacturers use minimal finishing to preserve the fiber's natural character, while others aggressively finish to maximize immediate softness, though this can reduce durability. The final product emerges from these treatments, transformed from industrial textile into the luxurious fabric consumers recognize. Now you understand the hidden complexity behind cashmere, the reason a simple sweater commands hundreds of dollars, the explanation for why authentic cashmere feels incomparably different from imitations, and the reality that true luxury fabric requires expertise, technology, and craftsmanship far beyond what most people imagine. Every cashmere garment represents a journey from the harshest environments on Earth through some of the most sophisticated textile manufacturing processes humans have developed. But cashmere isn't the only everyday product hiding an unexpectedly complex manufacturing story. Have you ever wondered what noodles are really made of? That simple food you've eaten countless times involves industrial processes that would surprise you, from the precise chemistry of dough formation to the high-tech equipment producing millions of servings daily. The science behind perfect noodle texture, the unexpected ingredients beyond flour and water, and the engineering required for those familiar shapes reveal another hidden world of manufacturing complexity. That video just appeared on your screen, and it's going to change how you think about one of the world's most common foods. Click it now to continue discovering the secret processes behind everyday products. Before you go, hit that subscribe button to join our community of curious minds exploring the hidden manufacturing stories behind the products that surround us. And here's a question for the comments. After learning about the complexity of cashmere production, do you think the price is justified, or does it still seem excessive? Share your thoughts below. I read every comment and love hearing different perspectives. The world is filled with objects we touch, wear, and use every day without understanding their origin stories. But once you peek behind the curtain, once you see the human ingenuity and industrial sophistication required to create even simple things, you develop a deeper appreciation for the manufactured world around us. That's what this channel is about, revealing the hidden complexity, the unexpected science, and the fascinating engineering that transforms raw materials into the products defining modern life. See you in the next video, where we are stepping inside a noodle factory to uncover secrets the food industry rarely discusses.